Okay, so 5, 6, and 7, those 3 small chapters are going to come together to be our last test. And chapter 5 is all about normal distributions and z-scores. Z-scores we talked a little bit about in chapter 2, so now we're going to get like really in depth with those over the next couple sections. Okay, so this isn't on your handout, nothing you really need to write down right now. We've got some more specifics that you'll see a little bit later on there. Okay, so first we're going to talk about a normal distribution. We've seen this picture before. These are our bell-shaped curves. Few properties that these have, the mean, median, and mode are all where you see that mean in the middle there. It's our line of symmetry. Also, the total area under the normal curve is equal to 1. We saw that a little bit with our probability distributions. If you remember our probability distributions, those were normal, and the sum of all the probabilities was equal to 1, so therefore the total area would also equal 1. So this is going to relate to those probabilities back in a little bit. Also, it's important to note that it never actually touches the x-axis, just kind of hovers above, gets really, really close on the left and the right there, so even if it looks like it does, it never actually intersects it. Okay, the other property that these have, if we now label my x-axis, we've seen these labels before when we talked about that empirical rule where we said like 68% was within 1 standard deviation and 95 and 99.7, if you guys remember that. If we put those numbers on there where we're 1 or 2 or 3 standard deviations out, 1 standard deviation out, a vertical line to my standard curve will create what we call an inflection point, or we can find an inflection point and use that to calculate our standard deviation. An inflection point is where the curve changes from concave up to concave down, or vice versa. Those of you that have taken calculus, you'll recognize those words, concave. If you haven't taken calculus before, if you remember back to like when you learned about parabolas, we had parabolas that opened down, and then we had parabolas that open up. So it's where the curve changes from opening down to opening up. That's that inflection point. And it's at 1 standard deviation. So you can either kind of eyeball where 1 standard deviation is, or you can find that inflection point to find 1 standard deviation out. Okay, so this is, I think, the first slide that you guys have on your paper there. For these 3 graphs at the bottom, all normal curves, we want to use the inflection points and the curve itself to find the mean and the standard deviation. So the mean is just where you see that little dashed line going straight up and down. So what's going to be that mean for that first one on the left? 3.5. And then the inflection points are labeled here for us. You can drop a vertical line down, and it's going to be symmetric on either side, so really you only need one of them. Your standard deviation is that distance between the mean and where we drew that inflection point line. So it looks like it hits at about 5, so the distance between 3.5 and 5 would be a standard deviation of 1.5. Okay, does that make sense? Okay, so what would be the mean for the one in the middle there? Also 3.5. And then this one has a smaller spread in the data, so we should expect a smaller standard deviation. Remember, that's what standard deviation is. It's how far spread my data is. So the wider my curve, the bigger my standard deviation. The narrower my curve, the smaller my standard deviation. If you drop a line down, I would say this one is about at 1 unit from that mean. Okay. And then what about the last one? My mean is 1.5 for this one, and the standard deviation, if you draw that vertical line, is approximately at, how far out are we? Maybe about 1. Yeah. Okay. And these are, again, approximations. So if you were answering these on a quiz or a test, if you were within, like, you know, so many units of that, depending on how it was labeled, you would get credit for it. Okay. All right. Let's look at this picture. Oops, did I skip one? Maybe? No, I want this one first. Okay. Which of these normal curves has a greater mean? Can you tell me? Which of these normal curves has a greater mean? Okay, perfect. Okay, so when we talk about greater mean, we talk about like the top of our hill, that line of symmetry. Which one has a greater standard deviation? A or B? B has a greater standard deviation because it's a little bit wider. You guys will do one of those in a minute. Okay, this one's on your paper. It says the scaled test scores for the New York State Grade 4 Common Core math test are normally distributed. The normal curve shown below represents this distribution. What is the mean test score? And estimate the standard deviation of the normal distribution. I'm going to get my little line tool here to make my life a little bit easier. Okay, so from the top down is my mean. Can you tell me approximately where that's hitting? $305. That sounds good. Okay, and then to get standard deviation, I need to find that inflection point. And this, again, is the part that's kind of a little bit of an approximation here. So I'm going to say my inflection point is maybe about there. Okay, and the more of these you do, the more you'll get used to about how far one standard deviation is going to be. And you can draw a line across. It should be symmetric on either side. Then we can take a line down. Looks like it's hitting again between 2 there. And remember, we're counting by tens on this axis, it looks like. So what would you say the standard deviation is? About 40, right? No? 305, 10, 20, 30, 40. I would say about 40. Okay. Again, we're estimating here, so if you gave me an answer between like 35 and 45, if your line looks a little bit different, that's fine. Okay? Any questions? All right. So you guys try these real quick then. All right, which one has the greater mean, A, B, or C? B. Which one has a greater standard deviation? Which one has the smallest standard deviation, if it asks that? A would have the smallest standard deviation. Good. Okay, the one on the right, what is the mean weight approximately?
3,300.
Yep, and standard deviation? 3,300, there we go. About 600, yeah. Okay. Questions on that? Just reading our normal curves. Good. Okay. So now, once we have a normal curve, we can add a word to it. Make it a standard normal curve. And you have this on your paper, this little picture here. So when we make it a standard normal curve, we are standardizing this picture. So instead of seeing whatever our data values are at the bottom, or +1 standard deviation, +2 standard deviations, +3 standard deviations, we now have 0, 1, 2, 3, -1, -2, and -3, which are z-scores. You guys remember calculating that before. So z-scores tell us how far we are from the mean in our normal curve. So if I have a z-score of -2, it means I'm 2 standard deviations to the left. Or if I have a z-score of 3, it means I'm 3 standard deviations to the right. The area under the curve is still equal to 1. Couple facts that we're going to see at the bottom here. First of all, when it says cumulative area is area to the left of that specific number that we're looking at, okay? So if I want the area to the left of -3.49, which would be like way over there, we pretty much say, because it's so far down on that side of the curve, that it's approximately 0 is the area to the left of that. And if we want the cumulative area for a z-score of positive 3.49, because that number is so far to the right, we say the cumulative area is pretty much 1, because we are encompassing pretty much our entire curve. That's going to be important because we're going to use a z-score chart in your packet in a little bit here, and numbers beyond negative and positive 3.49 are not on there. So if you have a number bigger than 3.49, smaller than negative 3.49, you're just going to use 0 and 1 for those numbers. Cumulative area, when we have a z-score of 0, which is our mean, is just 0.5 or 50%. We saw that before when we were talking about our empirical rule. We know 50% of the data is to the left of the mean and 50% of the data is to the right of the mean. And then, of course, as we go from left to right, the cumulative area is going to increase because more of our data is covered. Okay. So, using your table of values, if we have nice, pretty whole numbers, we can use the empirical rule with those percentages we talked about before. But most of the time, our z-scores are not nice, pretty whole numbers. So we use tables of values in technology to figure out what the area to the left or to the right or between specific values is. In your packet, you guys are looking for table 4. It's right after, it's the first table after all the formulas that you have on there. Table 4, and it's two-sided. One side of table 4 is all your positive z-scores, and the other side of your table is all of your negative z-scores. This table tells you cumulative area or area to the left. And if you don't remember that, there's a little picture at the top of the table that shows it's shaded to the left. So that's what all of these numbers are. It's the area to the left of that specific number. Okay? So let's say I wanted to find the cumulative area that corresponds to a z-score of 1.15. Here's how you would find that. So you're going to find the positive side of your packet, which I'm on the negative side, the back one. Okay, so I'm going to find a z-score in the column that says 1.1 is where I'm going to go down to first, for the row that says 1.1. And then I'm going to go over to 0.05, and then you guys should see we have that 0.8749 is the number that you should be able to locate. So what does that number mean? If I were to sketch that, and a lot of times we see shaded curves with these type of problems. There's a normal curve. 1.15 is just a little to the right of 1 standard deviation. And that number, that 0.8749, is the area in to the left of that, in that shaded region. So it's telling me about 87% of the curve is shaded to the left of 1.15. Okay? Good? Make sense? All right. Find the cumulative area that corresponds to a z-score of negative 0.24. So we're just locating these in the charts, all we're doing. Okay, so for this one, you're going to go to the negative side of your chart. You're going to find negative 0.2. You're going to go down to that row. You're going to go over to where it says 4, for the last digit, and that is 0.4052. Okay, and again, if you want to check it, negative 0.24, it's just a little to the left of my mean. Maybe like there, shade there. I could probably draw it a little bit further to the left. It's about 41% of my data is located in that region, to the left of negative 0.24 standard deviations. I'm going to skip the next one. Just cross that one out. We'll do some more practice on the next page. Let's go to 2.375. Okay, so your chart only goes to 2 decimal places. This guy is 3 decimal places. So how we find this, 2.375 is between 2.37 and 2.38. So we're going to locate both of those and then just find the midpoint, add them up and divide by 2. And then that's the value that we're going to be looking for. So if you find 2.37, going to be right next to each other, we get 0.9911 is the area to the left of that. 2.38 is 0.9913. So if I added those up and divide by 2 or just find the midpoint, I would get 0.9912. It's right in the middle of those. Okay, so if you've got that extra decimal place, just find what it's between, add them up, divide by 2. Questions there? Okay. You can use your calculator to calculate these as well. Honestly, it's, I think, just as quick to find it in your table. But technology does give us a few extra decimal places if you actually need it. So I can show you how to do that real quick if you want. It's also a way to check what you're finding in your table if you like to. So let's say I go back to that first one that we did, that 1.15 z-score. If I want to do that, the commands that we're going to type in or that we're going to see are to the right there. To get that normal CDF, we're going to hit second and then vars. Right above vars, it says DISTR, which means distribution. So that's the menu that we're going into. Okay, so second, vars, right below your arrows there. And then we're going to hit normal CDF. Okay, and then it's going to ask for 4 things. Those 4 things are listed in the parentheses, what you see at the right there. So if I have an area to the left of 1.15, we're calculating what you see in blue there at the top. It's, bless you, it's going to ask for a number to the left and a number to the right, and it's going to find the area between them. Well, we want pretty much the area all the way to the left of 1.15. So we just need to pick a really, really small number. So that's what that negative 10,000 is. It can really be any really big number, like you could put in, I don't know, negative 1,000,000 if you want to. Doesn't really matter, but it just needs to be a really small number because we want all the way to the left. Okay, and then the upper is where we want it to stop. That's the z-score we're finding, 1.15. And then the last 2 things, we just use our standard values. We have a mean at 0, that's right in the middle of our curve, and then a standard deviation of 1. And then if you hit paste, or just hit enter a few times, it'll spit out for you 0.8749, which is what we found before, but then you get a few extra decimal places with it. Okay? Make sense? Yeah? Okay. So let's go to the next slide. Let's practice a few more. In these, we're going to find the area and we're going to shade it. Find the area under the normal curve to the left of negative 0.99. So to be able to shade that, it's pretty much 1 standard deviation to the left, and that's pretty much that inflection point we were talking about. If you're not sure where to shade at, guys, remember you have this picture, so you can use this picture to figure out where to draw that vertical line at every time if you're not sure, okay? So about 1 standard deviation, it's going to be maybe right there, okay? And it's, again, area to the left. So there's my picture. And now I'm just going to find it on my chart, negative 0.99. Let's see. 0.1611. That's it. Okay. All right. The next one's a little bit different. This one says area to the right of 1.06. So again, 1.06, pretty close to 1 standard deviation, but it's positive, so it's on the right side. Maybe like there. Okay, shade it that way. I'm going to look up 1.06 on my chart, but that's not going to be my final answer. Remember, the only thing the chart gives us is the area to the left. Okay, so 1.06, if I find that number, I get 0.8554. So if 0.8554 is to the left, how do you think we can use that number to get the area to the right? Any guesses? Yep, it's just a complement. We know the total area under the curve is 1. So just like what we did with probabilities, we can subtract. 0.1446. Okay. Find the area under the standard normal curve between a z-score of negative 1.5 and positive 1.25. Okay, so negative 1.5 is going to be maybe like there, 1.25 maybe here, and this time it is an area between that we are calculating. But Okay, bless you. Okay, so I'm going to start with the bigger one. I have a z-score of 1.25. I'm going to look that up on my chart and find the area to the left of it. Again, that's the only place to go to start. So positive 1.25 is 0.8944. If I look up a z-score of negative 1.5, you can think of it as negative 1.50 to get that second decimal place there. And that would be 0.0668. Okay, so what do these numbers tell us? So from 1.25 to the left is about 89% of my area. From negative 1.5 to the left, so this guy, is about 7% of my area. So how could I use those two numbers to figure out the shaded region? What do you think?
Could you subtract 0.0668? 0.8944?
That's it. Bigger one minus smaller one. So the bigger one is here all the way to the left, but I don't want this. So I just take that little piece away, which is the 0.0668. Right. So bigger minus smaller if you're finding area between. Make a little note to yourself for that one if you want to. 0.8994, or no, 8944. There we go. 0.8276 would be the final answer for that one. All right. Is this making sense? Any questions? Okay, the last three are yours to try, and we're going to put answers up on the board. Shade it and find the area that is required.